Here is a concept brief over free fall, the next unit of study we'll be looking at. Still in Unit 1, Intro to Kinematics. And so if we're following along in our notes here, we have our focus question, which is essentially, how does gravity affect an object? Well, it's pretty straightforward. It obviously pulls things down to the center of the Earth. But one of the things that we're going to distinguish is it's an acceleration. Gravity actually accelerates things down, and we call that free fall. So once again, really important with the definitions that we use. So an unsupported object falls towards Earth with the same acceleration. All objects fall with the same acceleration. That's very important. I could have a penny or an F-150, and they would fall at the same rate. They would land at the same time when dropped from a height. So that's important to realize. We call this G. Sometimes we say negative G. It depends on what we're looking at. So A sub G is negative 9.8 meters per second squared. You might have seen that number before. Sometimes you'll see books use negative 10 to simplify some of the calculations, but we're pretty good at this. We're going to use that 9.8. And in the absence of air resistance, all objects accelerate at the same rate regardless of their mass. So once again, that's talking about that whole penny versus truck thing. And the negative sign indicates that the acceleration is down. So things fall down after you throw them up. That makes sense. And when the only force acting on the object is the force of gravity, the object is said to be in free fall. So when we drop an object, when we throw an object, the only thing touching it after it leaves our hand is gravity. That's in free fall. So I have a cool little animation here. What we're seeing here is an object being thrown up at initial velocity of 20 meters per second. And we see as it goes up, the velocity changes. At the apex of its path, it's 0, and then it falls back down. That's interesting. So one of the things that we have to notice, is you see the red 10 meters per second squared? That's my gravity, right? Gravity never turns off. Gravity is touching the ball the whole time through. So wink, wink, nudge, you're going to see this question a lot. What is the acceleration due to gravity at the top of its path? We better say 10 or 9.8. So once again, gravity never switches off. At the top of the path, or the apex of the path, we're going to have the velocity is 0. It's not moving for a micromillisecond. So for that tiny moment in time, it's not moving. And if we notice the way the blue stuff is changing, on the way up, the velocity is positive on the way up, but notice what's happening to the size of the arrow, right? It's slowing down on the way up, and then velocity is negative on the way down. It's speeding up on the way down. So if we remember our little idea about how vectors are pointing each other, if acceleration and velocity oppose each other, it slows down, and if they're the same direction, they speed up. And so make sure you can understand which way the vectors are pointing, acceleration and velocity, if it's in the up direction or the down direction. Wink, wink, nudge. That might be important later. And then the last thing that's really important, there is a constant acceleration of negative 9.8 meters per second squared the entire time. So it's always going to be accelerated. And then symmetry helps here. As long as the object ends at the same height, the final speed is the same as the initial speed. And so I'm saying speed on purpose there. The initial velocity is 20 meters per second, but the final velocity is negative 20 meters per second. So that's important to realize. We have to distinguish how the question is worded. Speed versus velocity is pretty important in terms of how we answer those questions. And then again, the speed and velocity at the top is 0 of the path. So let's make sure we understand that piece there. Then I have two worked examples, and we'll obviously jump more into this in class. But here's my first example. What is the velocity of a dropped object after it has fallen for 3 seconds? So always write the givens here. I have my initial velocity is 0. Anytime an object is dropped, we say it has 0 meters per second. It's not moving yet for that small moment in time. It's given me the time of 3 seconds, and it doesn't explicitly say that, but I'm assuming we're on Earth, so we have to use negative 9.8 for meters per second squared. We did forget my squared there. Shame on me. The equation that is most appropriate here is this VF equals V naught plus AT. So one thing to note, all of those kinematic equations that we have learned how to use now are valid for free fall and in that direction. So I plug everything in. VF equals 0 plus negative 9.8 meters per second squared times my time. And notice I get a velocity of 29.4 negative. So this told me it was pointing in the down direction, and that makes sense. I dropped an object, it's falling down, and we have decided that down is the negative direction, so that makes sense. If I had to ask for the speed, we would have said positive 29.4, so make sure we can distinguish between how the question wants that, whether the positive or negative, velocity or speed. So last example here, we have an arrow launched straight up from the ground with an initial velocity of 23.4 meters per second. In part A, sorry about the typo here, but how long until it reaches its highest point? Part B, how fast is it going at its highest point? And part C, how long does it take to reach the ground? Again, so the first thing I did is I sketched a diagram of what's going on here. I have my ground level with my initial velocity pointing in the up direction. At the apex of its path, or the very top, it's 0, and that's just kind of one of the properties of these kinds of questions. I have gravity pointing down, negative 9.8 meters per second squared, and the red dot diagram trying to indicate the down motion, so it's going to be clumpy at top and then spread out on the way down. That means it's just speeding up on the way down. Okay, so the first thing I do, I'm going to write my givens here. I have 23.4 for my initial speed, or initial velocity, and then my acceleration due to gravity, negative 9.8. So what I did here, I said v sub t, that's velocity at the top, is 0, and for that black phase, the black dots over there, the final speed, or the final velocity of the object is going to be 0. So I'm going to use the first kinematic. I picked the first kinematic there. I have 0 equals 23.4 plus negative 9.8 times t. So when you crunch those numbers, you should get 2.38 seconds. So that's how long it takes to reach its highest point. We could actually use a couple of the other kinematic equations to figure out how high it is. So we will be doing those exercises when we get into class. Part B is asking how fast it's going at the top, and so that's one of those things that we just know about this stuff, right? The velocity at the top is 0. It's not moving for that half a micromillisecond there. And then part C, how long does it take to reach the ground again? Well, that's a kind of an interesting question. So because of symmetry, it takes the same amount of time to go down that it takes to go up. So what I would do is I would get that 2.38 number, or however long it takes to go up, multiply it by 2. Here I would get 4.76 seconds to go from the ground level all the way up, all the way back down to hit the ground again, and you would get 4.76. So another question we could ask, there's various questions we can ask, there are probably multiple parts to this, but I could ask, what is the final velocity of the object? And in this case, we would say negative 23.4. It's just the same speed, but in the opposite direction. So remember, they're going to have the same speed. That magnitude, 23.4 in this case, is going to be the same, that initial velocity and final velocity. The arrows are obviously indicating the velocity, which one is positive or negative. So just some things to keep straight. If you have any questions, let me know. Thanks for watching. I'll catch you guys later. Thanks. Bye.